Welcome to the deep dive. We're here to cut through the noise and really get into the details from the sources you've given us. And today, we're diving into something that I bet feels really familiar if you're anywhere near cybersecurity. Just picture this for a second. It's Monday morning, right? You've run your big vulnerability scan Nessus, maybe NMAP, whatever tool you use, and what lands on your desk? It's not some neat little summary. No, it's thousands, maybe tens of thousands, of lines of just raw text. This huge, sprawling report that honestly feels less like useful intel and more like, well, just instant dread.
Yeah, that feeling is universal, I think, in the field. That's the before picture, isn't it? It's this endless manual grind. You're wading through this digital mountain of data.
Exactly. Trying to pick out what's actually critical, separating the real risks from just informational noise. Then you've got to figure out what's actionable, track it somehow.
Right. And it's not just tedious, it's a massive bottleneck. It slows down everything that matters, actually fixing things, responding to incidents, and crucially, showing you're compliant.
And that burden falls hard on folks like ISOs, information system security officers, and ISSMs, the managers, right? They're the ones who have to somehow turn this data avalanche into something structured, something you can act on. It's this constant fight against just being buried in information.
And we absolutely need to be clear here. This isn't just about, being annoyed by too much text. The stakes are incredibly high. That whole manual sifting process, it's riddled with potential for human error, for misinterpretation, and that directly impacts the most critical security processes we rely on. Think about the risk management framework, the RMF. That manual data handling affects the prepare step, gathering your system info. It affects the assess step, finding the vulnerabilities. And it definitely affects the ongoing monitor step, keeping track of changes. Any inefficiency there can really compromise things.
Okay, so it touches basically everything.
Everything. And it flows right into creating a plan of action and milestones, the POA&M. How can you build a clear, trackable plan when your starting point is this jumbled mess of text that isn't even formatted consistently?
Right, makes sense. Garbage in, garbage out, sort of.
Pretty much. And when those manual errors creep in, and they will creep in, they aren't just little oopsies. They can lead to serious legal trouble, huge financial penalties, even damage to your organization's reputation. We're talking about failing to meet requirements from laws like FISMA, Hero Pay, PCI, DSS. Those fines can be massive. And even more seriously, these bottlenecks in processing scan data, they can completely derail a system's authorization to operate. It's ATO.
Yeah, the ATO, that's critical.
Absolutely critical, especially for systems handling sensitive or classified data. If you can't get or maintain your ATO because you can't efficiently process and act on vulnerability data, critical missions can stall. We're talking millions of dollars wasted, potentially impacting national security. So the real challenge we're looking at is moving from that painful before, the text-based chaos, the errors, the delays, to an efficient, intelligent after, where we have streamlined, automated insight. How do we make that jump?
Wow, okay. That before picture is pretty bleak when you put it like that. An endless cycle of sifting, stressing, and potentially missing critical stuff. So let's unpack this. What if I told you there's a powerful tool, actually an elegant solution, that can take that messy pile of raw text and transform it, turn it into neatly packaged, genuinely actionable insights, something that makes your life not just easier, but way more effective, more strategic? That's what this deep dive is all about today. We're introducing you to the hero tool, PowerShell. We're going to dig into its unique object-oriented pipeline, what that actually means. We'll see it work with some really practical examples that should hopefully trigger some aha moments. And then, crucially, we'll connect these scripting skills directly back to those real-world cyber challenges, especially parsing those nightmare vulnerability reports. Our mission really is to equip you, our listener, with the understanding to be a more effective, more proactive cyber pro. So let's bring on the hero. PowerShell. Now, if you've worked in IT at all, especially in Windows environments, you've definitely heard of PowerShell. But maybe your first thought is, okay, it's just another command line, right? Like Bash on Linux. And that's a totally fair question. They look similar at first glance.
It is a fair question, but that's where the crucial difference lies. And it's not just a minor technical detail. It's a fundamental shift in how things work. You're right, Bash, which is everywhere in Linux and Unix, mostly deals with text streams. Just lines of text.
Okay.
PowerShell, on the other hand, operates on objects. That's the core distinction. It's not just about what you type or what you see, it's about the underlying data structure and how incredibly rich it is. To really get this, that assembly line analogy is perfect.
Let's hear it.
Okay, imagine that old school assembly line, the text-based one. Think of Bash commands like grep or sed as workers on this line. Each worker gets this messy pile of raw materials, just unstructured text.
Right,
Like,
like the output of a command.
exactly. Now, if you want that worker to find something specific, say a product name or an ID hidden in that text, they have to manually sort through the whole pile. They have to figure out how to cut out the piece of text they think is the right one, maybe do something small to it, and then they pass another messy pile of text to the next worker down the line.
Who has to do the same thing all over again.
Yes, sort, cut, extract, interpret. It's super inefficient, and it's incredibly brittle. If the format of that text changes even slightly, like an extra space or a date formatted differently,
Yeah.
your whole script breaks.
In there painfully.
We've all been there. Each worker needs really explicit, detailed instructions on how to parse that specific input, often using complex, regular expressions, basically pattern matching in a sea of characters. It's like telling someone, find the third word after the second comma, but only if the line starts with XYZ. It's guesswork.
Okay, that sounds fragile. So what's the PowerShell way?
Now picture the object-oriented assembly line. This is PowerShell. Here, each worker we call PowerShell command cmd-lets receives a neatly packaged item. Not raw materials, but a structured object.
An object, okay.
And this object comes with clear labels, we call them properties, saying exactly what it is. Its name, its ID, its status, its size, creation date, you name it. It's all clearly defined. And it even has built-in buttons, we call them methods, that let you perform specific actions on that object.
Ah, so the object knows stuff about itself and can do things.
Precisely. So when this object gets passed down the line, the next CMDlet knows exactly what it's getting. It doesn't have to guess or parse text. It can directly look at the status property or the ID property.
Yeah.
It knows what actions, what methods are available. It just interacts with that structured data. Then it passes that perfect structured item to the next CMDlet.
That sounds much better, more reliable.
Dramatically more reliable,
Yeah.
far less error-prone, way more efficient, because you're working with data that carries its own context, its own intelligence. And just as a side note, PowerShell CMDlets follow that consistent verb-noun naming convention, get process, set content, stop service. That consistency makes it much easier to learn and predict command names too.
That assembly line comparison really does make it clear. All those times scripts broke because some tool vendor tweaked their text output format. So this object-oriented way fundamentally changes how you work with systems. No more guessing how to parse text strings. You're directly manipulating structured data with known properties, known actions. That seems incredibly precise. What was the big aha moment for you when this really clicked, especially thinking about security?
For me, the biggest aha was realizing the sheer depth of information you get instantly without doing any extra work. With text output, like from IPS and Linux, if I saw a process name, that was pretty much it. If I needed its ID or who owned it or how much memory it was eating.
You'd have to run another command, right? And then try to match things up.
Yeah, it's exactly. Another command, parse more text, try to correlate the lines. It was this manual, often frustrating puzzle. But with PowerShell objects, when getProcess gives you that process object, it's not just the name. Bam. You instantly have the process ID, the user it's running as, the start time, the full path to the executable, CPU usage, memory usage, even its parent process ID. It's all right there, bundled together, directly accessible as properties of that object.
Wow, okay. All in one go.
All in one go. And this is absolutely vital in cybersecurity. Think about analyzing security logs with get event log. You're not just getting lines of text, you're getting structured event log objects.
Yeah.
Each one has properties like event ID, source, time created, the actual message text, everything neatly packaged.
So you can filter on event ID directly, not just grep for a number in the message.
Precisely. Or using get wmyObject or get SimInstance to query really deep system configuration details. You're always dealing with structured data, not just text you have to painstakingly interpret afterwards. This means way faster analysis during incident response, much more accurate auditing, and far less chance of missing some critical detail buried deep in a verbose text log.
So while Bash with grep said, awk is still king for unstructured text in Linux.
Oh, absolutely. It's incredibly powerful for what it does, especially in Linux environments. No question.
But PowerShell's real strength comes out when you're dealing with data that has structure, especially in Windows where so much of the OS is built around these objects.
Exactly. It allows a level of precise programmatic interaction and automation that text-based parsing just struggles to match in terms of reliability and efficiency, particularly in complex systems like Windows.
That makes total sense. Having all that context right there at the data point, instantly usable, that changes the game. Okay, we've got the concept of the object pipeline. Let's make it really concrete now. Let's walk through that practical example you mentioned, the one that gives that aha moment. Seeing the magic happen, turning concept into action. The command was get process, where object process name, jish eq, bad process, stop process. Simple but powerful.
Perfect. Yeah, that one-liner is a fantastic illustration. Let's break it down piece by piece, thinking about our object assembly line again. This time, our job is finding and stopping a specific, potentially malicious process named bad process. So we start with get process. As we said, this isn't just printing names. It's querying the OS, grabbing all the running processes, and wrapping each one up into a full process object. Remember, each object is loaded with properties: process name, ID, CPU, memory, start time, owner, path, and those methods, actions it can perform. This is worker number one on our line, creating these detailed, labeled items. Think about how much info about each process would be lost or hard to get if this just spat out a text list of names.
Right, you'd lose all that context.
Exactly. Then comes the pipe operator. This is the conveyor belt. And crucially, it doesn't just send the process name along. It sends the entire collection of process objects with all their properties and methods fully intact to the next CMDlet. No text parsing happens here. The rich, structured objects are passed directly. It's like handing over a complete file folder for each process, not just a sticky note with its name. This avoids all that messy text manipulation you do trying to parse payload or task list output.
Okay, objects flowing down the pipe. Got it. What's next?
Next stop, where object process name -eq bad process. This CMDlet is our smart filter, our quality control station. Now that symbol, that's a special automatic variable in PowerShell. It simply means the current object being processed right now from the pipeline.
So as each process object comes through,
As each process object arrives from getProcess, where object looks inside it, it doesn't need to guess or parse. It directly accesses the process name property of that object because it knows it's a process object, and it knows it has a process name property.
direct access.
Nice. Very nice. Then it uses the eKey operator, which is a reliable type-aware comparison, to check if the value of that process name property is exactly equal to the string bad process. Only the process objects that match this condition perfectly are allowed to continue down the pipeline. Everything else gets filtered out. This precision is critical when you're targeting something potentially harmful. You want zero ambiguity.
Makes sense. Filtered objects move on.
Right. And then we hit another pipe break. Same job as before. It takes the filtered collection of process objects, hopefully, now just the ones named bad process, and sends them still as complete objects to the final CMDlet.
Which is stop process.
Exactly, stop process. This CMDlet does what its name says. It terminates processes. And here's the payoff, the elegance of the pipeline. Stop process is designed to accept process objects as input.
It knows what to expect.
It knows exactly what to expect. Since it received those structured process objects, complete with their unique IDs and everything else needed to identify them, it can act on them directly. No ambiguity, no extra lookups, no guesswork based on potentially unreliable text parsing. It knows precisely which processes to terminate because the objects themselves contain all the validated information. It's the final worker, taking the perfectly packaged, correctly filtered items and performing the intended action with absolute certainty. You're not killing a process based on an ID you scraped from text. You're telling the object representing that process to stop itself.
That is incredibly clear and powerful. Breaking down that single line really shows the precision you get. You're directly working with system resources based on their actual properties, trying to replicate that reliably with just text manipulation.
Wow. It would be a nightmare. You'd likely need multiple commands, fragile regular expressions to find the process ID and text output, hoping the format of task list or EPS doesn't change in the next OS update. Error handling is just far more brittle.
Yeah, so this PowerShell example isn't just some neat trick. It's a real glimpse into how you can manage and secure systems with much greater precision and reliability. You know exactly what data you have at each step. It definitely feels like a huge leap from that frustrating before picture. Okay, that process example really hammered home the object power, but let's be real, managing local processes is one thing. What about those monster vulnerability reports we started with? The Nessus scans, the NMAP outputs that just make your eyes cross. Can we apply the same object-oriented thinking to cut through that kind of chaos? Can it actually pull useful, actionable intelligence from those files?
Yes, absolutely. And this is where these scripting skills go from being nice to have to absolutely essential for anyone serious about cybersecurity. Because you're right, the challenge with those reports is huge. Nessus often spits out XML. NMAP can too with the OX flag. trying to manually dig through thousands, sometimes millions, of lines of XML to find the critical vulnerabilities, the affected hosts, the specific plugin IDs. It's not just slow, it's incredibly error-prone.
I can imagine. Missing one critical finding because you scrolled past it.
Exactly. It happens. People spend days manually reviewing these reports, and critical stuff still gets missed. This leads to compliance failures, unpatched vulns getting exploited. It's a major problem.
So how do we tackle this? You mentioned objects.
Right. And this is where other powerful scripting tools, particularly Python, often come into play and work really well alongside PowerShell. Python is fantastic for data manipulation and parsing, mainly because it has such a rich library ecosystem. For XML specifically, Python has a brilliant library called xml.etree.ElementTree. And the best part, it's built in.
Built in, so no extra installs needed.
Nope, it comes standard with Python. And what ElementTree does is let you parse an XML file, transforming it into a structured tree-like format in memory. It's very similar conceptually to how PowerShell turns a running process into an object with properties. You're taking that raw XML text and turning it into structured data you can navigate programmatically.
Okay, so you're essentially creating an XML object in Python.
That's a great way to think about it. So let's imagine walking through a Nessus XML report with Python and ElementTree. First, you load the file using et.parse. That builds the tree structure. Then you can navigate this tree. Typically, you'd look for specific XML tags. For instance, you might iterate through all the report host tags to deal with each scan machine one by one.
And inside each report host?
Inside those, you'd look for report item tags. Each report item usually represents a single finding, a vulnerability, on that specific host. Now, the script can easily filter these report items. A common need is to find only the critical vulnerabilities. Nessus reports often mark these with an attribute, maybe severity 4 or severity critical.
So you can filter just like where object in PowerShell, but using Python logic on the XML tree.
Yes, exactly. Find the items where the severity attribute matches 4.1. And once you've found a critical finding that way, here's the power. You extract the specific pieces of information you need directly from the XML elements and their attributes. No more guessing based on line numbers or keywords. You directly access the name attribute of the report host element to get the host name. You grab the plugin ID and plugin name attributes from the report item element.
So you're pulling out named data fields.
Precisely. You extract things like host name, plugin ID, plugin name, maybe the vulnerability description. Then you store this information neatly, perhaps in a list of Python dictionaries, where each dictionary represents one critical finding.
Nice and structured. Yeah.
Very structured. And finally, Python has another excellent built-in library, the CSV module. You can take that list of dictionaries and easily write it out to a clean CSV file. Think about the advantage. No more fragile string searching. You're robustly accessing named elements and attributes in a structured document. The script is far more reliable, easier to maintain, and the CSV output. That's a direct, actionable input for your remediation teams or your PO&M process. It dramatically cuts the time from getting the scan results to actually starting the fix.
That Python approach sounds incredibly clean and practical, especially being cross-platform. But you position PowerShell as the hero for Windows shops. What if you're deep in a PowerShell environment, maybe managing Windows servers or working for a DoD contractor where PowerShell is often standard? Can PowerShell handle that XML parsing with the same kind of object-oriented power, or do you really need to switch over to Python for that?
Oh, absolutely not. You don't have to switch. PowerShell is definitely up to the task and maintains its object-oriented consistency even when dealing with XML. It has native capabilities that are really powerful. For example, let's say you ran nmap with nmap to get that XML output.
Okay.
In PowerShell, you can often just read the content of that XML file into a variable, say one map file content. Then you can directly cast that string variable into an XML object like this, XML map XML object, one map file content.
It's just like that, XML.
Just like that. PowerShell parses the string and instantly transforms it into a navigable XML object hierarchy right there in your script. Suddenly, that big block of XML text becomes something you can explore using dot notation, just like any other PowerShell object.
So you could do something like nenmap XML object.emiprim.host.
Exactly. You can drill down. One map XML object.emiprim.host would give you the host nodes. Then maybe one map XML object.emiprim.host to .ports.port to look at the ports on the first host. It's very intuitive if you understand the XML structure.
Wow. And can you use the pipeline with this XML object, like where object?
Absolutely.
Yeah.
And this is where it gets really powerful again. You could take those port objects, pipe in the where object, and filter for specific properties within the XML structure. For instance, where object state EQ open to find only open ports.
Okay, just like the process
Sounds
example.
like the process example. You could even combine conditions, where object type HEQ open and visual service.name, like HTTP, to find open web servers. Then follow that up with select object to cherry pick the exact pieces of information you want from the XML structure.
Yeah.
Maybe you want the host's IP address, which might be in host.address.adir, the port number ported, and the service name. You can grab just those things
And then export CSV.
and then pipe it straight into export CSV to get that nice structured report. But PowerShell has another trick up its sleeve for XML that's even more powerful for complex queries. The Select XML CMDSS. Yes. This CMD lets you use XPath expressions. XPath is a standard language specifically designed for navigating and selecting nodes within an XML document. It's incredibly precise. You could write an XPath query like hostportsport at state open, and it ported 1024 service to directly find all services running on open, non-privileged ports across all hosts in the report in one go.
Whoa, okay. XPath sounds powerful, but maybe a bit complex.
It had a learning curve, definitely, but it's extremely efficient for complex XML structures. So PowerShell gives you options: the intuitive dot notation for simpler structures, and select XML with XPath for more complex targeted queries. Both methods fully leverage PowerShell's object model, bridging that gap perfectly between our simple get-process example and the real-world complexity of parsing vulnerability reports. It shows just how versatile and consistent PowerShell's object approach is, whether you're dealing with live system processes or static XML files.
Okay, that's really compelling. Knowing PowerShell can handle this directly is huge for Windows-centric environments.
And these scripting skills, whether in Python or PowerShell, they aren't just about parsing files faster. They directly support and seriously upgrade those critical RMS steps we mentioned earlier.
Right, connect it back to the framework. How does this help with RMF?
Okay, think about the prepare phase. Scripts can automate gathering system info, checking configurations, identifying potential scan targets, feeding right into defining your system boundaries accurately, much faster than manual inventory.
Makes sense. What about assess?
That's where it's indispensable. You automate the analysis of those Nessus, NMAP, or ACES scans. Instead of someone manually reading thousands of findings, a script filters prioritizes based on severity or asset criticality, maybe even groups findings. This generates precise inputs for your security assessment report, the SAR, mapping directly to specific controls. It turns days of analysis into minutes or hours.
Huge time saver. And monitor.
Essential for continuous monitoring. You can schedule scripts to run scans daily, weekly, whatever makes sense. They parse the results automatically, compare them to the last scan's baseline, and instantly flag new vulnerabilities or configuration changes that violate policy. This is true continuous monitoring, not just periodic spot checks. It's proactive, not reactive.
Okay, and the PONNM, the action plan.
The structured output, that CSV file we talked about, with host names, plugin IDs, severity, maybe even suggested fixes, that feeds directly into creating clear, measurable, time-bound POANM items. You have the precise data needed to define the corrective action, assign it to the right team, and set realistic deadlines. It makes the POANM actionable and trackable.
And that helps with the final authorization step.
Massively, because
Yeah.
you have structured, repeatable, evidence-based proof that you are identifying, tracking, and managing risks effectively. It gives the authorizing official much higher confidence in the system's security posture. It's not just gut feeling. It's data-driven assurance.
It really ties the whole life cycle together. You mentioned other tools too, like Nipper and ACS.
Right, just briefly. Nessus is your broad vulnerability scanner. NMAP nails network discovery and port scanning. Nipper is different. It's a configuration auditor. Great for checking router, firewall, switch configs, especially in air-gapped networks where you can't actively scan. It analyzes the configuration files. But guess what? Nipper reports often come in structured formats like XML or JSON. So our parsing skills apply there too, letting you automatically check device configs against hardening guides or STIGs.
Okay, so config analysis too, and ACS.
ACS, the Assured Compliance Assessment Solution, is the big one for the DoD. It's really an enterprise ecosystem for vulnerability management. And guess what's often at the heart of ACS? Nessus scanners and Tenable's Security Center for Central Management. So the skills you learn for parsing Nessus reports are directly applicable within the ACS framework, just often at a much larger scale. It shows these parsing and automation skills aren't tied to just one tool. They're foundational abilities you can apply across your entire security toolkit, whatever scanners or auditors you use. You learn the principle, you can adapt it.
That really drives home how these scripting skills are more than just convenient automation. They seem fundamental, pulling us out of that reactive, manual before state. But let's broaden the lens a bit. Beyond making the day-to-day easier, why are these skills truly essential? Not just for aspiring cyber pros, but maybe for anyone working in tech today. What's the bigger picture impact on security posture and even careers?
That's exactly the right question to ask because the impact is huge and stretches way beyond just parsing scan reports. First off, it's absolutely critical for risk mitigation and compliance. Let's bring back the CIA triad. Confidentiality, integrity, availability.
The fundamentals.
The fundamentals. Being able to quickly parse scan results means you can identify immediate threats to these pillars much faster. That NMAP script finds an unexpected open file share port, SMB. That's a potential confidentiality leak or availability risk via ransomware. Act on it now. Nessus script flags critical systems missing patches needed to prevent remote code execution. That's a massive integrity risk. Scripting shortens that critical time between discovery and remediation, shrinking the attacker's window of opportunity.
So faster response equals lower risk.
Significantly lower risk.
Yeah.
Then think about compliance standards like STIGs, the Security Technical Implementation Guides from DISA. These are incredibly detailed hardening guides, hundreds, maybe thousands of specific settings for an operating system or application.
Yeah, STIG checklists are notoriously long.
Exactly. Manually verifying every single setting across dozens or hundreds of systems. It's practically impossible to do accurately and consistently. Scripting lets you automate that verification. You can write scripts that query system configurations using PowerShells, getItem property, gets instance, etc., and compare them directly against the STIG requirements. This isn't just good practice for DoD systems. It's often mandatory for getting and keeping that crucial authorization to operate, ATO. Scripts provide the evidence that you're compliant, turning days of manual audit prep into potentially minutes of execution.
Automating the audit evidence collection, that's huge.
It's a lifesaver for compliance teams. And it extends to broader frameworks like NIST SP 853, the big catalog of security controls used by the federal government and widely in industry. Automated parsing and configuration checking helps you pinpoint security control gaps, areas where you're not meeting a required control. For example, Control AU6 is about audit review, analysis, and reporting. A script can automate parts of that review, flagging anomalies in logs much more reliably than a human scrolling through them. The structured output from your vulnerability parsing scripts directly informs the select, implement, and assess phases of the RMF by showing exactly where controls related to vulnerability management, like RA5, are weak or failing.
So it connects directly to specific controls.
Directly. And for cleared contractors dealing with classified information, there's DAPM Appendix A V2.2. This document gets extremely specific, tailoring NIST controls with very strict, granular requirements. Scripting becomes almost essential to rapidly verify compliance against these unique and demanding standards without incurring massive manual effort and cost.
Okay, so risk and compliance are major drivers. What else?
The second huge piece is efficiency and scalability. Let's face it, the threat landscape changes daily. New vulnerabilities pop up constantly. Enterprise networks are growing, becoming more complex with cloud, IoT, containers. Manual review just cannot keep pace. It doesn't scale. Automation through scripting is honestly the only viable way to maintain a strong, responsive security posture in this environment. It's the key to enabling genuine continuous monitoring, as RMF Step 7 calls for. You can't have humans manually reviewing every critical log and config setting every single day across thousands of assets. It's impossible.
So scripts become your tireless digital security assistants.
Exactly. They work 24/7, processing data volumes that would completely overwhelm a human team, and they don't get tired or bored. This frees up your human analysts to focus on the complex threats, the incident response, the threat hunting, the things that require human ingenuity. The ROI in terms of reduced operational cost and increased security effectiveness is massive.
Makes sense. And the third point, careers.
Yes, career advancement. This is huge on a personal level. For roles like ISO and ISSM, mastering these scripting skills fundamentally changes your value proposition. You evolve from someone who primarily manages checklists and pushes paper based on manual reviews into a strategic analyst and even a security solutions developer.
From data sifter to data strategist.
Perfectly put. You automate the repetitive grunt work, the parsing, the checking, the basic reporting. This frees up your time and mental energy to focus on the higher-level questions. What do these findings mean in our specific environment? What are the underlying systemic issues causing these vulnerabilities? What proactive steps or custom tools can we build to prevent this class of problem in the future? That's the high-value analytical work that defines a modern, effective security professional.
So it lets you operate at a higher level.
Much higher.
You become someone who identifies trends, builds custom automation, proactively shapes the security posture, rather than just reacting to scan reports after the fact. And the sources we looked at are explicit about this. Skills in scripting, tool development, and parsing are often listed as a strong preference or even a requirement for more senior security roles. It demonstrates initiative, technical depth, and the ability to scale security efforts. It's a clear differentiator that makes you far more valuable in the job market. It's the difference, honestly, between being seen as a security administrator versus a security engineer or architect.
That's a really powerful framing. Moving from that manual data sifter to a strategic analyst, automating the grunt work to focus on what really matters. It feels less like just learning a tool and more like fundamentally shifting your approach, becoming more analytical, more proactive, and ultimately way more effective at actually shaping your organization's defenses. You move from constantly fighting fires to strategically building fire breaks. Okay, we have covered all our ground today. Hopefully, we've managed to transform that initial, frankly depressing picture of cybersecurity frustration into one that feels more like empowered action. We started with that very real pain staring at thousands of lines of raw text from Nessus or NMAP, that overwhelming before
Yeah,
scenario.
the pit in your stomach moment.
Exactly. Then we introduced PowerShell, our object-oriented hero, and really unpacked its powerful pipeline. We looked at how it moves beyond simple text to handle structured objects, turning messy data into clean, actionable insights.
And that get process, where object stop process example really drove it home, right? That aha moment of seeing the precision.
Definitely. It showed the potential almost surgically. And then crucially, we bridged that concept to the big real-world problem. Parsing those massive Nessus and NMF XML reports. We saw practical ways to tackle it using both Python's ElementTree and, importantly, PowerShell's own native XML handling capabilities, using dot notation and even XPath with select
We're
XML.
showing the versatility. And beyond just the how-to, we really dug into the why these skills are absolutely essential for truly effective risk mitigation, for actually meeting compliance mandates like RMF, STIGs, NIST 853, APM.
And for achieving the efficiency and scalability you just can't get manually.
Exactly. We highlighted how scripting directly supports every key step of the RMF. Prepare, assess, monitor, creating actionable POA&Ms, and ultimately supporting that critical authorization decision. Mastering these core skills, understanding the PowerShell pipeline, getting comfortable with XML parsing in Python or PowerShell, it's not just resume padding. It's a fundamental competency for any serious cyber professional today.
Yeah.
It lets you move beyond just finding vulnerabilities to efficiently managing them, prioritizing them based on real risk, and actually driving their mitigation. You become a force multiplier.
So the message is clear then.
I think so. Our call to action for you, our listener, is really straightforward. Get your hands dirty. Don't just take our word for it. Actively practice these skills. Try out PowerShell's pipeline. Grab a sample NMAP XML file and try parsing it with PowerShell or Python. See the power for yourself. And there are great resources out there. Go straight to the source. Check out Tenable's site for Nessus info. That's tenable.com, Forest Products, Nessus. For Nmap, the Bible is nmap.org. If you're interested in config auditing, look at nipper.nipper.nl. And for the DoD folks needing ACS info, Tenable has resources like tenable.com/solution briefs assured compliance assessment solution, ACAS powered by Tenable.
And there are tons of tutorials online too, right?
Absolutely. YouTube is full of great walkthroughs for Nessus, Nmap, ACSS, PowerShell scripting, Python XML parsing. Find tutorials that match your learning style. Just dive in, experiment, build those muscle memories. Truly empower yourself with these incredible, frankly, career-defining tools.
Couldn't agree more. The world of cybersecurity, it's always changing, always evolving. New threats, new technologies, new complexities pop up every day. But that fundamental need for sharp, efficient analysis, for robust automation, that's constant. These skills we've talked about aren't just technical tricks, they feel more like strategic superpowers in this field. So dive in, experiment, and give yourself those powers. They really are keys to unlocking a more effective, way less frustrating, and ultimately a much more impactful future for you in cybersecurity. And as you think about all this, maybe mull over this final thought. Imagine a critical system gets its authorization to operate. But this time, it's not just based on point-in-time manual checks and auditors flipping through bunkers of reports. Imagine its security posture is continuously verified by automated, script-driven assessments, constantly checking for vulnerabilities, constantly validating configurations against benchmarks. How much more trustworthy, how much more genuinely resilient does that system become? What new possibilities open up for proactive defense? For focusing on the truly hard problems, when the tedious, error-prone tasks become reliably automated, freeing up human expertise for the strategic challenges that only we can solve.